Okay, as I promised, here's a change of basis example. So let's consider a basis B that has vectors 1, 1 and minus 1, 1 in it, ordered basis of course, and a basis C that has 2, 0 and 0, 1 in it. And we like to find the transition matrix, or matrix that will take us from vectors in C and convert them to vectors written in terms of B. So from the previous example, or from the previous video, we saw that the way we do that is we augment B with C, and we remember the order in which to put them by looking at the purple or magenta rectangle there. That tells us the order, so that's why we use that type of notation. B with the backwards arrow C. So we need to do the augmented system here. So we put the basis vectors for B on the left, 1, 1, minus 1, 1, and the basis vectors for C on the right, 2, 0, and 0, 1. And then we multiply the first row by minus 1 and add. That's how we get this portion. So we get 1 minus 1, 0, 2, 2, 0, minus 2, 1. Then we need to divide the second row by 2, giving us this. And so the last step will be to multiply the second row by 1 and add it to the first row. And we'll see that at the top here. And so when we do that, we end up with our matrix. It takes us from C to B, being what's over here on the right-hand side of the augment, similar to what we did when we were finding inverses. We solve for both right-hand sides simultaneously. So that matrix is, the matrix first row is 1, 1 half, second row is minus 1, 1 half. So now we have this matrix P that takes us from C to B. So if we're given a matrix that's written in terms of C, and want to find out what it looks like written in terms of B, we can just simply multiply by this matrix here. So let's take a look at what we have. Let's say we had the matrix that is written in terms, the vector written in terms of C, and to make it simple, we'll make that vector 1, 1. So that means in terms of the basis vectors, these are the coordinates for the basis vectors in C. And so if we look up here, we can actually see what that vector looks like in terms of the standard basis, because we just make the linear combination. So 1 times 2, 0, which is the first basis vector in C, plus 1 times 0, 1, which is a second basis vector in C, gives us the vector 2, 1. And so 2, 1 is what the vector 1, 1 written in terms of C is actually in terms of the standard basis. So we sometimes use that standard basis so we can compare vectors that are written in terms of different bases, because of course if they're both written in terms of the standard basis, we know what they look like. So as a first part of this problem, I'm going to write C and have written C in terms of the standard basis to see that that is the vector 2, 1. So now we're ready to multiply and see what happens. So we're going to take our matrix P that takes me from C to B, multiply it by a vector written in terms of C, and that should give us our output written in terms of B. So let's do that now. So we get 1 plus a half, so x of B, its first component will be 1 plus a half, or 2. And the second component will be minus 1 plus 1 half, which is minus 1 half. And let me see here. I think that 1 plus a half is not equal to 2, but it's equal to 3 halves. So let me make that correction here. Make sure I add and subtract correctly, so you can double check that. But that first component should be 3 halves. Second component should be minus 1 half, provided I did the matrix multiplication correctly, and I'm certain that I have. Okay. So what does that mean? Let me just go back here and grab this part right here. I'm going to copy something over to the other side. Let's not do that. Let's do it a little better here so you all can see it. Now I'm going to get it. Give me just a second. Well, it's giving me a hard time, so I'm just going to write it. That's 3 halves and minus a half. So x written in terms of b is 3/2 minus 1/2. And so if I remember those basis vectors from b, because I want to see what this looks like in terms of the standard basis so I can compare, it's going to be 3/2 times the first basis vector, which was 1, 1, plus a minus 1/2 times the second basis vector, which was minus 1, 1. Adding those together, I get 3/2 minus minus, so 3/2 plus a half, which is 2, and 3/2 minus a half, which is 1. And so if I take the coordinates 3/2 and minus 1/2 and multiply them times the basis vector in b, I get that vector translated into the standard basis as 2, 1, which was exactly what I got when I looked at the coordinates of the vector written in terms of c and multiplied those by the basis in c. So let's just go back and look one more time. Here we got the 2, 1, and if we go back and look over here, we got 2, 1 when we did the same thing for the coordinates of the vector written in terms of c. So I hope that helps.